Hello, I'm Seon Kim.
And I'm Ush.
We came from Seoul, South Korea. We're going to talk about the clean air with Lotus mask. This is our abstract. Our questions are that people often wear masks to protect themselves from fine dust. Disposable masks sold on the market not only have a low fine dust blocking index, but also have a high risk of contamination or bacterial infection of the material. Thought the reason for this problem was the propagation of toxic substances or microorganisms left in the mask due to the body structure of the mouse with a humid and warm temperature. So we tried to study how to solve this problem. To find a more accurate direction for the study, we found out that the Lotus effect is a hydrophobic property applied to the windscreen in the car, and hypothesized that using the method can prevent residual toxic ingredients and microorganisms in the mask. If you absorb lotus leaves when it rains or showers, you can find something unusual. Lotus has larger leaves than other plants, but strangely enough, they bounces off the raindrops or spill this stagnant water as if it were coated, and dust on the surface of the leaves is washed down together, so the leaves can always be kept clean after it rains. Now we are going to talk about our hypothesis. We need to solve this problem in which air containing external harmful ingredients remains inside the mask. Masks have to improve their performance as filters and remove physical shells and reduce the absorption power of the inner. In this process, we plan to separate air containing fine dust or harmful ingredients. Our background researches are about first the mask, second the filtration, and the membrane separation. Now we're going to talk about the experimental procedure. First, we prepared materials to make microspill with hydrophobic properties on the inside filter surface of the mask. These pictures are what we have done to check the effect of lotus leaves. Then, we tried to reduce the experiment error by making 5 filters in total. Finally, we tested the differences between samples before and after filtration using liquid chromatography. This is the principle we use to analysis. This is high-performance liquid chromatography. And this is inductive combined plasma atomic emission spectroscopy.
And now we are going to talk about data analysis and discussion. During analyzing, the results were compared and analyzed using 2 controls and 6 experimental groups. And the following graph shows the difference of distilled water with mask and without. Based on the results of the experiment that demonstrated the usability of the mask, Control 2 and XP125 were compared, but there was no difference between XP122 using nose pack and face pack. However, there was a significant difference Control 2 and XP325. And graph 2 showed a change in the amount of heavy metal ions detected over the time of ultrasonic waves. Next, as a result of LC analysis was possible to maximize the effect of removing harmful ingredients from masks by increasing surface tension. And this graph shows the relationship between ionic concentration and temperature. The results were analyzed in order to verify the ability to remove heavy metals. The graph 4 shows the heavy metal ion analysis using IC. Experiments have raised questions about the effective use time of the mask while waiting for analysis. Since we had to know how long the use time would be effect and what time should be used, we measured the efficiency of mask installation by air pressure difference of the back of the mask. And the following graph is the result. Finally, the conclusion is we tried to solve the situation in which air containing external harmful components remained inside the mask while moving through the mask with hydrophobic properties on the surface of the mask's internal structure was solved by a physical-chemical method. The physical-chemical properties of the filter surface were changed and confirmed through experiments to improve the performance of existing mask filters and to allow harmful substance from outside to be discharged when exhaled using airflow. The water repellent Lotus leaf effect is due to numerous small bumps on the surface, so the droplets remain round without spreading due to surface tension. Experiments have confirmed the effectiveness of masks using these Lotus effects. It is possible to maximize the effect of removing harmful components by creating fine bumps and increasing surface tension. And we cited some papers before starting experiments and preparing presentation. Thank you for listening.